Welcome to the Day 1 video, which is Section 5.1, Graphing Quadratic Functions. We have two objectives for today, which are listed at the top. We're going to graph quadratic functions in standard form, and then we're also going to graph and interpret minimum and maximum values. So minimum and maximum we've calculated before, we're just going to calculate it in a new way today, and then we're graphing in standard form. Later, we're also going to be graphing in vertex form, so there's two forms. We're going to start off with some vocabulary. So the first one is a quadratic function. This is a function or an equation where the largest term is x squared. That's the highest power. So I don't have x to the third, I don't have x to the fourth, I don't have anything above x squared. The general equation in standard form is y equals ax squared plus bx plus c. And in this case, a, b, and c are just constants. They're just some numbers. We have three vocab terms from the graph. The parabola is the U shape of a quadratic, which you can see right here. The axis of symmetry is a vertical line that cuts the parabola into two symmetric parts. Those parts are mirror images of each other. So if you'll notice, here's where the axis of symmetry is. And then that gives us this half and this half. They're exactly the same, they're just mirror images. So one's backwards of the other. And the vertex is the highest or sometimes lowest point. So here's our vertex. In this case, it's the highest point, it's the maximum. And that's where the axis of symmetry goes through. So the vertex is kind of where it all starts. It's where our graphing is going to begin. So that's just some background vocabulary. We need to know that in order to be able to graph. So if we move on, you'll see we have two halves. On the left is just the general rules for graphing, and then on the right is the example that we're going to do. So to graph, the first thing that you have to find is the vertex. In order to find the vertex, we do x equals negative b over 2a, and then you would substitute x back in order to find y. The equation for the axis of symmetry is exactly the same. The difference is the vertex should be some point, x comma y. Whereas the axis of symmetry is actually an equation, like x equals 4, x equals 2. The y-intercept is going to be 0, comma, some number. So you have to substitute 0 in order to find the y-intercept. You're always going to do a table of values, so I'll do that one with you in the example, and then you're going to graph. Your graph is going to be a parabola, so it's going to be somewhere here, up, down, etc. You're always going to have an axis of symmetry that goes through it. And then you're always going to have a vertex. So I know this is a lot of information, so I think we're just going to jump right in and do an example. If we see example number 1, it says f of x equals x squared, add 4x minus 3. This f of x just tells us that it's a function. So it's really the same as y equals. So first thing I'm going to do is say what a, b, and c are. A is the number in front of x squared. When there's nothing written, that's understood to be a 1. Our b is in front of the x, so that's a 4. And then our c is the number that doesn't have an x, so that's negative 3. Okay, so to find my vertex, I need to do x equals negative b over 2a. In this case, b is 4, so it's going to be negative 4 over 2 multiplied by 1. So negative 4 divided by 2 is going to be negative 2. Okay, so that's my axis of symmetry right away, is x equals negative 2. Okay, but now I need to find the y-coordinate of the vertex. This is just the x. In order to find the y, I need to substitute the x back in. So I have negative 2 squared, add 4 multiplied by negative 2, subtract 3. So I get 4 add negative 8, subtract 3. 4 add negative 8 is negative 4. Subtract 3 is negative 7. So my vertex ends up being negative 2 comma negative 7. Okay, so this is a way to start. Finding the y-intercept. It's going to be 0 comma some number. So I need to substitute in 0. I get 0 squared, add 4 multiplied by 0, subtract 3. So I get 0, add 0, subtract 3. So it's 0 comma negative 3. Okay, so I'm going to start by graphing all of that. My axis of symmetry, the x equals negative 2, is going to be a vertical line. You have to make sure you put x equals negative 2 so that we know that it's an equation. My vertex, which is on the axis of symmetry, is negative 2, negative 7, which is right here. Okay, and then I also have the point 0, negative 3. Okay, I need to have at least 5 points before I can graph this parabola. One thing that we notice is if this is our vertex, the graph is going to be opening up. The reason that is because of the a value. If a is positive, the graph is going to open up. If a is negative, the graph is going to open down. So next we need to make our table of values. The vertex always goes in the middle. Choose 2 lower, 2 higher. 0, negative 3 we already found. So let's substitute in negative 1. I get negative 1 squared, add negative 4, subtract 3. So negative 1 squared is 1. 1 subtract 4 is negative 3. Subtract negative 3 again is going to give me negative 6. Okay, I already substituted in negative 3 and negative 4. And I got negative 6 and negative 3 again. So this is another property of a parabola that you should notice, is these two numbers are going to match. These two numbers are going to match. That's because a parabola is symmetric. So the left and the right side of the parabola are going to be the same. They're going to have different x's but the same y's. So graphing those points, I have this one, negative 1, negative 6. I have negative 3, negative 6. And then I have negative 4, negative 3. Now I'm ready to finish off my graph. So that's what my first graph looks like. Okay, so let's move on to the next example. We are also going to do it together again. So I'm going to start by finding the vertex. The vertex is negative b over 2a. So let's start by identifying a, b, and c. A is negative 2, b is negative 4, and c is 6. So first thing, a is negative, so this is going to be opening down. Okay, so this becomes 4 over negative 4, which is negative 1. Now in order to find y, I need to substitute that back in. So I get negative 2 multiplied by 1, because negative 1 squared is 1, times 4 multiplied by negative 1, add 6. So this is negative 2, add 4, add 6, which is 8. So my vertex is negative 1, comma 8. That means my axis of symmetry is x equals negative 1. Because remember, it's just the x-coordinate of the vertex. My y-intercept is going to be 0, comma some number. Now if I substitute in 0, I get 0, subtract 0, add 6. So 0, 6 is my y-intercept. And now I need my table of values. Remember that the vertex always goes in the middle. Choose 2 lower, 2 higher. 0, 6 I already calculated because that's the y-intercept. So now I have 3 more that I need to substitute in. I'm going to start with the negative 3. So I have negative 2 multiplied by 9, subtract 4 multiplied by negative 3, add 6. So this is negative 18, add 12, add 6, which gives me 0. If I substitute in negative 2, I get negative 2 multiplied by 4, subtract 4 multiplied by negative 2, add 6. So this is negative 8, add 8, add 6, which just gives me 6. And then substituting in 1, I get negative 2 multiplied by 1, subtract 4, add 6, which gives me 0. And I know that I did this correctly because these 2 numbers match and these 2 numbers match. And they should because a parabola is symmetric. The vertex is going to be the only one that doesn't have a matching y. Okay, and now I'm ready to graph. I'm going to graph my axis of symmetry first. So my x equals negative 1. Okay, now my vertex is negative 1, 8. I have 0, 6, and negative 2, 6. And then I have 1, 0, and negative 3, 0. Sorry, this one didn't graph as well. Okay, and remember, this opens down because a is negative. We noticed that in the very beginning. So that's a good thing. That shows us that we're on the right track. From this, you're also going to have to be able to identify the domain and range. Our domain in this case is what x can be. So if I start here and I move left, my graph continues in that direction. So that means x is getting negative. If I go right, the graph continues that way also. So x is getting bigger. So the domain is all real numbers. Now if I look at my y values for the range, if I start at 0 and go up, the graph goes up for a little bit, but it stops. It hits this high point right here, which is where y is 8. If I go down, the graph continues that way forever. So my range in this case is y is less than or equal to 8. 8 is the highest point, and then it decreases from there. So I know that these problems are on the longer side, for sure. But you won't have as many of them when we're working in class. Okay, let's move on. So turn to page 9. Okay, maximum and minimum values. When a is greater than 0, so when a is positive, the graph opens up. So it's going to open up. So there's going to be a minimum. When a is negative, the graph or the parabola opens down, which means there's going to be a maximum. So right now we're actually going to find those values. Looking at example 3, it says determine whether the function has a minimum or a maximum. Well, our a is negative, so it's going to open down. Okay, if it opens down, that means I have a high point. So I'm going to have a maximum. Okay, the minimum or the maximum is where the vertex is. So when it says find the minimum or maximum value, it means find the vertex. So x is negative b over 2a, which in this case is negative 12 over negative 8, which simplifies to be, if I divide both by 4, 3 halves. So my minimum maximum value is going to be 3 halves comma some number. To find out what that number is, you need to go to your calculator. So when I do that, I get negative 4 multiplied by 3 halves squared, add 12, multiplied by 3 halves, add 18, and I get 27. So the way to write this is the maximum is 27 at x equals 3/2. Last thing is stating the domain and range. Domain is all real numbers. So my graph is going to continue infinitely in the left direction, infinitely in the right direction. So x is going to be getting bigger, it's going to be getting smaller, it can be all real numbers. Y, on the other hand, hits that maximum. So the biggest that y can be is 27, and then it's going to decrease from there. So my range is y is less than or equal to 27. Okay, right now, pause the video and try example 4 on your own, please. Okay, so part A, determine whether the function has a minimum or a maximum. Well, we have a positive A, which means it's opening up. If the graph opens up, we're going to have a minimum, a low point. Okay, now we need to find what that value is. So our negative b in this case is positive 24, because b is negative 24. A is 4, so 2a becomes 8. So this is 3. So your answer should be 3 comma some number. So going to the calculator, after I substitute in 3, I get negative 25. So the way to write your answer is the minimum is negative 25 at x equals 3. Last thing, domain and range. Again, my graph is going to continue infinitely to the left and right, so your domain is all real numbers. X can be whatever it wants. Range is the more difficult one. So if we notice from our little sketch, y is going to hit a low point and it's going to get bigger. So y is always going to be greater than or equal to negative 25, because negative 25 is the low point that it hits. So hopefully we got that one right. If not, hopefully we now know what we did wrong. So let's move on. We have 2 more examples together, and then you have a final example on your own. The next thing that we're going to do is find the minimum and maximum on the calculator. I want to start by doing example 5, and you're going to see me do the problem on a calculator, and then we'll write down the steps. Okay, so looking at example 5, it says find the minimum or maximum value. Looking at the function that we have, we see that f of x equals positive 12x squared. So the number in front of x squared is positive. That means that it's going to be opening upward, and we're going to have a minimum. Right now, if you could please get out your graphing calculator so we could start this example. Okay, so starting with the graphing calculator, you're going to be able to follow all of my steps following the red button. So go to y equals and put in the function 12x squared, subtract 21x, add 8. And what you're going to notice is that we have this x button right here. So use that x button for x. Next, I want you to hit zoom, and then we want the standard window. So go down to zoom 6, please, and hit enter. And then we should see our parabola, which we do. We're going to calculate our minimum, so go to second trace or second calc, and we want to calculate the minimum. So choose minimum, and you'll notice there's a maximum also. Okay, it says left bound, so we see the minimum, and we need to go to the left of it, and then hit enter. Now the calculator wants the right bound, so go to the right of that minimum, and hit enter. And then do you want to guess? Hit enter again. Yes, you want the calculator to guess. And this is the minimum value that we should get. Remember that the way to write your answer is that the minimum is negative 1.1875 at x equals 0.875. So that's the final answer. So I know that's a lot of steps to remember, but we should be able to remember that. Now that we've done the first example, let's write down the steps. So first step is to put your equation into y equals. Second step is you want to hit zoom 6, which is the standard window. Then you want to graph it. And then you're going to hit second calc or second trace and choose minimum or maximum, whichever one you want. You're going to have to go to the left and hit enter, go to the right and hit enter, and then hit enter one more time, and you should have your answer. Right now, pause the video and try example 6 on your own, please. Notice that we have a negative 8.3x squared. So before you do it, think, am I going to have a maximum or a minimum? When you've completed the problem, come back and we'll go over it together. Good luck. Okay, so this one should open down, which tells you that we have a maximum. So the maximum in this case ends up being negative 0.096 at x equals 0.84. So hopefully you got that one right. If not, I am going to show a quick video of what you should have done on the calculator. Okay, so this applies to what you should have done after you've already hit graph. So you put it in y equals, you hit zoom 6, and this is the graph that you see. Then you should hit second calc. This time you're looking for a maximum, so go down to maximum. Left bound, so go to the left of where the maximum is and hit enter. Go to the right of where the maximum is and hit enter. And then hit enter one more time. And that's the answer that we ended up with here. So it's the maximum is the y value at whatever the x value is. So hopefully if you got that one right, that's great. If not, hopefully you now know what you need to do on the calculator. Okay, I promise that we're almost done. Flip the page. Last example for you to do. So today we did a few things. We graphed in standard form, we found the minimum and the maximum, and then we used the graphing calculator. This is your final test to see do you get it. So when you come to class tomorrow, we will be checking that you have this graph completed correctly. Good luck!